Section 10.5 has to do with natural logarithms. Natural logarithms are logarithms with a base value of e. So just like common logarithms all have a base value of 10, natural logs all have a base value of e. E is actually equal to 2.178, and that's rounded off, kind of similar to what pi is rounded off. The value of e is derived by this equation. You have 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 2 times 3, and of course the next one would be 1 over 1 times 2 times 3 times 4, and it continues on and on. You actually have a button on your calculator that is the natural log. It's an LN button, okay, log naturally, if you will. You will find that button right here underneath the log button, okay, and everything about this is very similar to the common log. So if I were to ask you to find the log of the natural log of 3.925, you literally are just going to take your calculator, you're going to press that natural log button. Now notice that it looks weird. It looks like IN, but it's actually a lowercase ln. You'll see that in your book often. Then you'll put 3.925 into your calculator, and it's going to give you a value of 1.3674 rounded off. So if I was to find the natural log of 0.045, I press the LN button, 0.045, and it's going to give me a negative 3.1011 rounded off. So that's just simply calculator use. You also have anti-natural logs, just like you had anti-common logs. So if they were asked you to find x, you're saying the natural log of this number of x is going to give you that. So you are going to use the anti-log button. Now the anti-log button means you're going to press the second and then the LN button, and it's going to give you an e raised to a certain power. Okay, so then you're going to press in there 3.4825, and you're going to get 32.5410. Okay, then you're going to do the same thing on this one. You're looking for the x value. So in a sense, what you're doing is you're taking that natural log to the other side. So you can say the anti-log or the inverse natural log of 0.75 is what you're looking for. So second natural log 0.75, and it's going to give you an x value of 2.1170. This one again, you're trying to find x, so you're going to take the natural log to the other side. So when you do that, it becomes the anti-natural log of 5.4. So second natural log 5.4 is going to give you a value of 221.4064. The natural log is used in word problems. This one is actually in your book. It says Mr. and Mrs. Franco are planning to take a cruise for their 25th wedding anniversary. They have 6 years to save $3,500 for the cruise. If the 6-year certificate of deposit they buy now pays 8% interest compounded continuously, how much should they invest now in order to have at least $3,500 for the cruise? So you are going to use what's called the PERT formula. The principal and the natural e, if you will, raised to the r times t power. So the amount that I need is going to be greater than or equal to the principal times e raised to the rate times time power. So I need at least 3,500. The principal, I don't know. E has a value. it is raised to, the rate is 0.08 because I've got to take my percent, change it into a decimal, and I've got 6 years to do this. So I'm going to put a 6 right there. So basically I have 3,500, and then I've got the principal times e raised to the, let's multiply 0.08 times 6, and it's going to give me 0.48. If you would like, what you could do, now you could just take the natural log of both sides, but this is multiplied by the principal, so you could actually divide the 3,500 by e raised to the 48 power. You have an e button on your calculator. You can see it right here above the division. So I've got 3,500 divided by e raised to the 0.48 power, and it's going to give me a amount that my principal has to be at least $2,165.74. So here's another one similar to that. It's not in your book. Suppose you have $250 that is deposited into a savings account. The interest is 10%, compounded continuously. When will the original deposit be doubled? Okay, so doubled means 500. Okay, and I'm going to use the PERT formula. This time I know the principal. The principal is 250 times E. I know the rate is 0.1. What I don't know is the time. Okay, so what I'm going to do, now this one's going to have to be done a little bit different. I'm going to go ahead and this is my unknown. I know my E. Okay, so what I'm going to do is I'm going to divide the 250 into both sides. So that's going to give me 2 is equal to E raised to the 0.1 t power. Well, notice that the unknown is up in my exponent. So what I have to do is I have to take the inverse log, okay, ln of 2 is equal to the ln of E raised to the 0.1 t power. This has a value, so I take my calculator, the inverse log, or the natural log of 2 is rounded off 0.6931. Now on this side, understand, it's just like what we were doing before. It has a base of E. Those two numbers match, so the actual value is 0.1 t. So all I have to do to solve for t is to divide both sides by 0.1. And that's going to give me t is equal to 6.9 years. So that's how long I would need to leave it in to double that amount. All right, your homework on this is page 624, 11 through 28 all, and a word problem of number 34.